This lesson deals with Supplemental Problem 6.1. You can find this problem in the course ebook in the Chapter 6 Supplemental Problems on page 1. In Chapter 6, around page 2, we introduced a low-pass filter using a resistor and a capacitor. There are many circuits that can make a low-pass filter, and here's one with an inductor and a resistor. Let's just see if it makes sense. When the frequency gets lower and lower, j omega L, and its impedance gets smaller and smaller. In the limit, it becomes a short circuit. The output equals the input. As the frequency increases, the impedance of this element gets bigger and bigger, and in the limit, j omega L would approach infinity as omega approaches infinity. And that would block the signal between the input and the output, so we get a gain of 0. This has the characteristics of a low-pass filter. I'd like you to sketch the magnitude of V out over V sub S and the angle of V out over V sub S versus omega. We just have a voltage divider. The output voltage here is going to be the input voltage V sub S times the impedance R over j omega L plus R. Let's divide through by R. We have 1, and then a 1 over here, and then j omega L divided by R. In Chapter 6 on page 5, we defined the form of a low-pass filter, and it was 1 over 1 plus j omega over omega C. In this case, omega C is R over L. For the values of R of 1K and L of 10 millihenries, omega C is equal to 1K divided by 10 milli, and that's 100 kiloradians per second. In Chapter 6 on page 4, we made a two-line approximation to a low-pass filter, where the actual curve is the dotted line here, and the slope was minus 20 dB per decade. The value of omega C is what we call the corner frequency, and that was right here. In this case, it's 100K. Now, if you divide by 2 pi, that's 15.92 kilohertz. That's the upper end of the audio band. But since we already did this sketch for this general form, all we gotta do is just change the axis to the value of omega C. Same is true for the angle. We did that on Chapter 6, page 5, and found that the angle started out at 0 and eventually went to minus 90 degrees. So 1 decade back from omega C, we were at roughly 0, and 1 decade above, we were at roughly minus 90 degrees. The actual curve is the dotted line here. There's a slope of minus 45 degrees per decade between 1/10 omega C and 10 omega C. But again, we've already done these sketches. All we do is just change the value of omega C to fit our problem. And this is Supplemental Problem 6.1.